Hello everyone, happy to see you here. Today we have a great algebra question. We know that the sum x plus y equal to 10 and the product xy equal to 20. We need to solve this question for x and y. So if you have your solution, your assumption, you can also write it in the comments below and then we will check our answers. Okay, so first of all, from this first equation, let's express our y. So y equal to 10 minus x. This is our first step. So y equal to 10 minus x. And right now, let's plug in this y right here to the second equation, but not y, 10 minus x. Instead of this y, we plug in 10 minus x to the second equation. So let's do it. So we have x times 10 minus x, and equal to 20. Right now, let's simplify this real quick. First of all, we can multiply this x by this parenthesis. So we have 10x minus x squared and equal to 20. And from this perspective, we have a quadratic equation, but we prefer a little bit different order. This minus x squared on the first position, so we have minus x squared, 10x on the second position. Let's do it, let's write it. So plus 10x and minus 20 from the right side, so minus 20 equal to 0. And the final tricky move, right here we don't like this negative sign because we prefer a classic order, and according to a classic order right here should be positive. So that's why we multiply both sides by minus 1. What do we have as a result? X squared minus 10x and plus 20 equal to 0. And right now we have a basic quadratic equation, and let's solve it with the basic method of coefficients. For example, first of all, let's write our first coefficient equal to 1, second coefficient equal to minus 10, and third coefficient c equal to 20. So we have our three coefficients, and let's plug in it into our formula. But first of all, every time I have a quadratic equation, I solve it for discriminant really quickly. B squared minus 4ac. As a result, what do we have? B squared, so minus 10 squared minus 4 times 1 times 20. 4 times 1 times 20 equal to, let's simplify this. What do we have? Minus 10 squared equal to 100, so 100 minus 80. 100 minus 80, and this is great news for us because right here discriminant is positive, is greater than 0. So it means that in this branch we have two real number roots, and in our case we have x first and x second. So let's solve this question for x first and x second. So x first and second equal to minus b plus minus square root of discriminant and all over 2a. Let's plug in everything. Let's plug in each of these elements into this spot. So we have minus b minus 10 plus minus square root of discriminant square root of 20 and all over 2a, 2 times 1. Let's simplify this. So minus 10 equal to 10. Yeah, plus minus. Square root of 20, this is not our table case, but we can express this 20 as 4 times 5, okay? 4 times 5. And all over 2. And a lot of students may be asking why 4 times 5? Because right here we can easily split our square root sign. We can write it as 10 plus minus square root of 4 times square root of 5. We can write it like that in terms of square root property, okay? All over 2. If you're interested in this property, I can easily write it real quick. So square root of a times b equal to square root of a times square root of b. So this is our property. Right now, let's continue. Right here, square root of 4 equal to 2. So we have 10 plus minus 2 square root of 5 over 2. And the final really great move, we're going to factor 2 from our numerator. So we have 2, and in parentheses we have 5 plus minus square root of 5. 5 plus minus square root of 5 over 2, okay? And right now, why do I factor this 2? Because right here we can easily cancel these 2 and these 2. And this is our final answer, 5 plus minus square root of 5. So x first and x second equal to 5 plus minus square root of 5 plus minus square root of 5. Okay, this is our x first and x second. Before finding y first and y second, I want to split it. First of all, I want to write x first equal to 5 plus square root of 5. Let's write it with the positive sign. And of course, x second equal to 5 minus square root of 5. Okay, and right now let's go back to the beginning, because we need to solve this question for y as well, because we have both, we have x and y. Y equal to 10 minus x, so let's remember it, just keep it in mind. So y equal to 10 minus x. So but y equal to 10 minus x. So right now let's solve this question for y first from here. So y first equal to 10 minus x first. So 10 minus x first. So as you can see, we will have two pairs, x first, y first, and x second, y second, okay? So y first equal to 10 minus x first minus this one, 5 plus square root of 5. Y first equal to 10 minus 5 and minus square root of 5. Okay, let's simplify this. So 10 minus 5 equal to 5. So y first equal to 5 minus square root of 5. As you can see right here, we have a symmetrical part. We have a symmetrical answer, because right here 5 plus square root of 5, right here 5 minus square root of 5. And right now let's solve our second part. Let's find our y second equal to 10 minus x second. The same thing, the same principle. Y second equal to 10 minus x second, 5 minus square root of 5. And y second equal to 10 minus 5 plus square root of 5. Y second equal to, right here 10 minus 5 equal to 5, so we have 5 plus square root of 5. As you can see, the same principle. We have two symmetrical pairs. I mean symmetrical in terms of our signs. And let's gather all the knowledge together, and let's write our final answer to this question, and then we will check our answers. Okay, so our answer to this question. So x first, y first. Right here on this part we have first pair. So x first, 5 plus square root of 5. And 5 minus square root of 5. This is our first pair. And the second pair, 5 minus square root of 5 and 5 plus square root of 5. 5 minus square root of 5 and 5 plus square root of 5. So we have two pairs, first pair and the second pair. And in the end, let's check our roots real quick. So our question from the beginning, x plus y equal to 10, x plus y equal to 10, and xy equal to 20. We have addition and multiplication, and I'm going to give you one really interesting hint, because addition is a really interesting and really great mathematical operation, because 2 plus 3 equal to 3 plus 2. So we can change these positions, x and y. That's why we don't need to check all of these pairs. We need to check only one of these. So for example, this one or this one, because x plus y equal to y plus x. So 3 plus 2 equal to 3, so 2 plus 3. So that's why we don't need to check both of these, because these roots are symmetrical and absolutely the same, but in a different order. So let's check, for example, according to this first pair. So 5 plus square root of 5 plus 5 minus square root of 5 equal to 10. So right here we're going to cancel this square root of 5, this square root of 5, and we have 5 plus 5 equal to 10. This root is absolutely great for us and absolutely correct. And in the end, let's check our multiplication, and also let's use this first case. So 5 plus square root of 5, 5 minus square root of 5. So we have two parentheses, x equal to 5 plus square root of 5, and the second one, 5 minus square root of 5. And one really interesting moment, because a lot of students might be thinking that how could we simplify it, maybe we need to multiply parentheses by parentheses, but I'm going to give you one really interesting hint, because in math there's one really important and really great formula. So for example, a squared minus b squared, difference of squares, equal to a plus b times a minus b. And right here we have absolutely the same thing. We have, for example, 5, this is our a, and square root of 5, this is our b. So we have a plus b times a minus b. So we can consider it as a difference of squares. So let's do it. So 5 square minus square root of 5 square. And as a result, right here we have 25 minus, right here we're going to cancel it, minus 5. And this one equal to 20. So absolutely the same thing as we have right here. So our roots are absolutely correct. And yeah, this is my solution to this question. I really hope you understand it. If you still have any question, write a question in the comments below. What do you think about it? And this is a great question for students, mainly for students, because first of all, this is not a hard question, and maybe for teachers, this is not a very interesting question. Maybe you're preparing for exam right now, and you might be thinking, okay, what question should I choose? Should I pick for my students? This is a great question, great relaxing question for students, a great system of equation, basic system of equation with the basic quadratic equation. So that's why this is a great question to practice, of course, on your exam or on different classes. It's also really great. So I want to say thank you everyone for being here. Thank you everyone for watching, for supporting my channel. It's extremely important nowadays, and I'm really happy, I'm really proud that we have a really great community, math community, a lot of teachers, a lot of students here, and it's extremely important to be the part of it, to do math content. And my main goal is to make math as clear as possible and of course understandable for students. And if this video is helpful in any way, I'm really happy about it, that this video maybe help you to prepare for exam. Or maybe you don't like math and you sometimes you like to watch this type of videos. It's extremely great, and I want to say thank you everyone for being here. I really appreciate it. Thank you for supporting my channel. Thank you that you're like the part of this community. It's extremely important for me, and of course your support helps me to go further, to be here on YouTube. And I want to say thank you, YouTube. Thank you for everything, for supporting my channel. Of course, about this question, write your questions in the comments below, write a suggestion, write your notes about this question, and see you in the next videos. Have a great day and take care of yourself.